All right, we're going to be looking at page 30 today. And again, the directions on this page were to work these problems as synthetic division. We're going to first work them as long division. All right? So we're on page 30. We're going to be doing long division here. All right? Now, I'm not going to work these out all the way. Maybe I will the first one, but the main thing I want to do is show you how to set these up, things to look for. Because number one, first of all, let's look at this. Reads as such. X to the third plus 4x squared plus 5x plus 2. And it says by x plus 1. Okay? Now, remember, this is your divisor. I should maybe put 4 here. This is what we call your dividend, right? Now, one of the things I want you to note with the dividend, the variable that this problem is in terms of x, okay? And you have a descending situation with the exponents on x. If you start with a lead term, the highest degree term is the lead term in these expressions, and it should always be so. If it's not, and you see it somewhere else, you need to rearrange the order of the terms so that the lead term of your dividend has the highest exponent on it, the highest degree. So, and you have a descending situation with the degree of the terms all the way down. X cubed, x squared, x, okay? So it must be in that descending order. Now, once you do that, your problem needs to, in setting it up, needs to look like this. You do the long division. X to the third, 4x squared, plus 5x, plus 2. Now, so we've got 4 terms in the dividend, 2 terms in the divisor. So that means we're going to be dealing with the dividend 2 terms at a time, because your divisor is 2 terms long. And what you're going to do is you're going to ask yourself, get the lead term of your quotient, your answer here, you have to say x to the third divided by x. So you're asking this question, x to the third divided by x. What does that evaluate to with x squared, right? No, smart board's not letting me write good too there. So x to the third, x squared. I'm sorry, I'm going to just say x squared there, okay? So taking the time to erase it. Y'all hear my voice, you see what it is, it's x squared. So I'm going to say x squared now times x plus 1. That's what I do. With this part of the quotient, I have to multiply by the entire divisor. X squared times x gives me x to the third. X squared times 1 is a plus x squared. Put parentheses around the expression and subtract. And you'll note the way this will end up working out is you'll have x cubed terms and x squared terms, in this situation, like terms, paired together so that you can easily subtract, deal with the numeric coefficient. The x cubed are going to cancel, right? Because they're additive inverses now. This plus x squared becomes a minus x squared, and you have 4x squared minus x squared. It's going to give you a positive 3x squared. Keep up with your sign, okay? Common mistake in some of the problems I've seen in the past is not keeping up with sign changes when you're subtracting. Now, bring down your next term. Just one more, right? So that my partial dividend is 2 terms long. I'm going to divide x into 3x squared. So now, to get the next term in my quotient, my answer is I have to ask this question. 3x squared divided by x, because that's the lead term of my partial dividend here. What does this evaluate to? What does it reduce to? 3x, right? So, and there's a positive 3x. So x squared plus 3x. So far, I've got the first 2 terms of my answer. 3x times the x plus 1 is what we have to do now. 3x squared plus 3x, right? 3x times x, 3x times 1. That's why I have these here. Subtract. 3x squared minus 3x squared, again, they cancel. Subtract, this becomes a negative 3x with a positive 5x. 2x, right? And then bring down your 2. We're getting close to being done here. All right? Now, we have to ask ourselves this. 2x divided by that x, the lead term of my divisor. We have to ask this question now. See a pattern here emerging? What is 2x divided by x? It's 2, isn't it? right? Because the x is canceled. So plus 2. So now what I'm going to do is take that 2 and multiply it by the divisor. And I'm going to get 2x plus what? 2. Okay? Now, this neat little situation doesn't always happen. In this case, it did. What do we get here? 0. Yeah. What that 0 means is there's no remainder. If I had gotten, after doing this last stage of the problem, a number down here other than 0, whatever that is, it tells me that this is the remainder. And it would be expressed as whatever number was right here would form your numerator. You'd make a fraction with that number being in the numerator and your divisor being in the denominator. So you would like say plus some whatever number over x plus 1. But that's not the case here because the remainder is 0. I like those problems, which means x squared plus 3x plus 2 is the answer. Okay? If I look at number 2, and I want to do this, okay? I'm not going to work the whole problem, but I want to set it up. Number 2 looks like this, because you can't just work it straight out the way I just did number 1. Number 1 was set up nicely for you. You know, you had the terms of your dividend set up in descending order already. Your divisor was in a good format right there with the variable first and your constant second, which is generally what you want. Number 2 is not quite so neat. It looks like this: 1 plus 2x plus 3x squared plus 4x to the third by 1 plus x. Technically, I don't really need to rearrange anything because of the way the divisor and the dividend is set up. I'm going to tell you, just to get you thinking consistently, I'm going to tell you for the time being, this is not the right setup, okay? What I want you to do, I want you to get into the habit of always seeing the lead term of your dividend have the highest degree on it. Technically, what they did here is not wrong, but what I want you to do is I want you to rearrange the order of the terms. The 4x cubed first, then the 3x squared, then the 2x, then the 1. Highest to lowest. Just kind of get into the habit of doing that, and you should be okay. And dividing, let's say not by 1 plus x, but let's change the order. Let's make it x plus 1, because that doesn't change the value of what, it just puts the variable first. Which now puts this in the same type of a format as number 1, right? So set it up the same way, do the division the same, and you should be okay. Right? Now, look at number 3 though. Number 3 is a little more jumbled up.
So you can rearrange it?
Yeah. Just make sure, by the way, if you do rearrange terms, if there's a minus sign in here, make sure you carry the minus with the term. You know, if this had been a negative 4x, if that had been minus 4x to the third, then my lead term would not be 4x to the third, but a minus 4x to the third.
So there's different answers for each problem? Like, I mean, if you rearrange it, you're going to get some.
No. If you don't order the terms properly, I got to be careful because I understand what the effect of what book is doing and how they order the terms in this problem. You won't be able to get the answer properly. You're going to find problems if you don't structure your problem appropriately. Let's just put it that way. You're going to find problems when you try to do the division. You're going to get this isn't working. Just do this, okay? Don't try to get too complicated with it. Just do that. But number 3, 5b to the third. This is what the problem reads. Plus 3b squared plus 4 by b plus 2, right? Now, what's the problem here? If you were to write this down, the dividend, the order that it's given to you, you're going to find problems in your division process. All right? You need to reorder these so that the squared term is where the minus 12b is, and the minus 12b is where the 3b squared is. But you got to make sure you take this sign with the 12b. It needs to look like this: 5b to the third plus 3b squared minus 12b. One mistake students might make is they might rearrange the order of the terms, but forget to move the signs with the term. And you don't want to forget that because that will affect your answer. So this is what you got as your dividend, and v plus 2 is out here, and then start your division process. Let me look at number 5. I'm going to jump down to number 5 here, okay? Because you've got to be careful with this. 4x to the 4th minus 3x to the 3rd minus 1 by x minus 1. Now, this is my dividend. Is it written in descending order?
Yeah.
But is it missing anything? It's missing something. What's it missing? I don't see a squared term in here. I don't see an x to the first power in here. I see a 4. I see a 3. And not only should it be in descending order, it needs to be, you can't miss a degree. I mean, the highest degree in this dividend is a 4, which means there needs to be a term with a degree of a 3. Yeah, got that. There also needs to be a term with a degree of a 2, and then a 1. Okay? And then your constant at the end. So in order to do the division, what you're actually dealing with here is this: 4x to the 4th minus 3x to the 3rd plus 0x squared. You got to do that to hold the place value of whatever x squared term might be in the answer, plus 0x for the same reason, and then put the minus 1 out here. You've got to do that. All right? If you don't, you're going to find problems in trying to execute the division. So, this is what you're looking at with x minus 1 out here, and then do the division process like we've done in the first problem, okay?
I don't see how you got this.
Which ones? These?
Yeah.
I invented them. Why can I do that?
Yeah.
Did I change the value of this expression by putting 0x squared and 0x in here? It's still 0, isn't it? Because 0 times anything is 0. By putting them in there, what I have done is I have secured the possibility for the answer to have an x squared term in it. Let's say if I didn't. I mean, there's going to be an x squared term in it no matter what. Okay, there will be. But let's say if I didn't do that. Let's say if I said x minus 1, so that you can see the problems that are going to come up. And let's say I kept it as written, minus, oh, that's a 4. Let me erase that. Okay, let's say that I didn't change anything. All right, and I just wrote the dividend underneath the division symbol as is written in the book, and I started doing the division process. Well, we start off, what's the question I'm asking to start with? 4x to the 4th over x, right? What does that reduce to?
4.
What? 4x to the 3rd. Okay, don't do anything with that 4, guys, okay? So, 4x to the 3rd. 4x to the 3rd times x minus 1. Okay, well, that's not so bad. I can see how I can put those together. 4x to the 3rd minus 1 times the negative 1. What is that? A negative 4x to the 3rd, right? All right. Now, not too bad of a deal now. I can subtract, right? I got like terms I can deal with. These cancel. That becomes a plus. That's a minus. So what's my answer here? A plus x to the 3rd, right? That becomes a plus 4. Don't miss your signs here. Negative, negative, positive. That's a minus 3. Negative 3 plus 4 plus x to the 3rd. Okay, bring down your next term. X into x to the 3rd. Now I'm asking this question, right? What does that evaluate to? I hope you tell me that. Right? So I get plus x squared, right? X squared times x minus 1, x to the 3rd minus What? X squared, right? I'm almost done. No, it doesn't work, does it? I can subtract here, but now see, I don't have like terms, which complicates it. And if you didn't put these zeros up here, x squared and 0x, you'd get here and go, I don't know what to do.
So why didn't they automatically just give them to you?
Because they're mean. They want you to see to put those terms in there. Okay?
So we could never solve that.
Well, it would be difficult, okay? You know, yeah. This is more of a systematic way to make sure that you can do the, by putting the 0x squared and the 0x in here, this allows for a systematic and methodical way to proceed to get your answer without going, what the heck do I do with this? You know, I don't know, right? Put the zeros in there. Oh, so if I had to put those in there, you know what I'd have here? I'd have 0x squared. Now I can deal with that. That becomes a plus x squared, 0. So I would have x squared down here, but y'all can finish the problem. I think if you put the zeros in there. This is, that's a frowny way to do it. Okay? This, that's happy way. Okay? All right.